Section 1.4, key math skills for chemistry. So in this section, there's a little bit about place values, positive and negative numbers. These are things that if you don't understand what a place value is, or how to identify a place value, or what a positive and negative number are, or how to identify them, or how to use them in adding and subtracting and multiplying and dividing and such, I need you to email me, contact me in some way, come to my office hours, and then we can go over it. It's so basic that I'm not going to waste time in here. What I could spend some time on are percentages. And a percent is the amount of an object collected divided by the total amount of the type of object that there is in a sample. And then you multiply that by 100%. Percent meaning for every 100. So if I have 100 pennies and I split that up between me and my child, I give her 63 pennies and I have 37 pennies, I would have 37% and she would have 63%. If we had 200 pennies and I have, let's say, 80, she would have 120. The percent that I would have would be 80, divided by 200 times 100%. 80 divided by 200 is 0.4 times 100%. This comes out to 40%. Now I'm using a simple case here, but if I have 80 out of 200, I would have 40 out of 100. I just divide the 80 by 2, essentially. My child would have 120 pennies out of the 200, and that is 60% of the total. And you can see 60% plus the 40%, that adds up to 100%. Sample problem 1.5 on page 12, I'm going to go over on the next slide. You can see here it says a bullet found at a crime scene may be used as evidence in a trial if the percentage of metals is a match to the composition of metals in a bullet from the suspect's ammunition. If a bullet found at a crime scene contains 13.9 grams of lead, 0.3 grams of tin, and 0.9 grams of antimony, what is the percentage of each metal in the bullet? And express your answers to the ones place. So, in order to do this, I need to find the total mass. And so, I'm going to write that as M sub T for mass total. That's just going to be the mass of lead plus the mass of tin plus the mass of antimony. And we get 13.9 grams plus 0.3 grams plus 0.9 grams. And we get a total mass equal to, let me do some math here, 15.1 grams. Now that we have the total mass, we can find the percent mass for each of those elements. And so, let me kind of erase a whole bunch of this. All right, now that I've given myself some more space, I can do the rest of the work. So the percent lead is going to be the amount of lead collected, which is 13.9 grams of lead, divided by the total mass, 15.1 grams. And you can see grams are going to cancel out there, times 100%. And we get 13.9 divided by 15.1 times 100. And we get 92.05%. But I'm going to round it to 3 digits because in percent lead. I'm going to round it to 3 digits because the numbers that I started with each had 3 themselves. All right, so that gives us the lead. All right. Now, What about the percent tin? The percent tin is going to be equal to 0.3 grams of tin divided by 15.1 grams times 100%, and we get 1.99% tin. Do the same thing for the antimony, and we get, there's actually two ways you could do this, but I'll do it the same way for antimony. And so the percent antimony is going to be 0.9 grams divided by 15.1 grams times 100%, and you get 5.96%. Now, if we take all three of those data and we add them up, we should get a number around 0. Hold on a second. All right. There. So we have 92.1% plus 1.99% plus 5.96%. When you add those up, you get 100.05%. And that is A-OK, because each of these numbers above, the 92.1 and the 1.99 and the 5.96, were rounded. When you have roundings in numbers that are then used in further calculations, you're going to get inherent errors. This 0.05% is due to those rounding errors. If you didn't use rounding numbers for each of those three percentages, they would add up to exactly 100%. So there actually is a second way where you could do it, and it doesn't really matter that much what you do. Say you did lead and tin first and you just didn't want to do that same process. You could just take 100 minus 92.1 and minus 1.99, and you would get the percent of antimony. And it comes out to 5.91% antimony. Now you can see that that is slightly different than the 5.96. Not that much different, but it is different. And that's okay. Either way is fine with me. All right, so, but you would have to show your work, basically.